Now, in this lecture, we'll find out the length of line segment MN. In the drawing, we have square ABCD. We know that one side of square ABCD is equal to 12 units. That is to say, AB equals to BC equals to CD equals to DA equals to 12 units. And inside this square, we have a circle and a semicircle. The center of this circle is at point M. The center of this semicircle is at point N, and we want to find out the distance between the centers of the circle and the semicircle. That is to say, we want to find out the length of line segment MN. So in the first step, we define the point of tendency of tangent AB with this circle as point P. We define the point of tendency of tangent BC with this circle as point Q. We define the point of tendency of tangent AC with this circle as point R. We define the point of tendency of tangent AC with this semicircle as point S. And we define the touching point of the semicircle with side DC of square ABCD as T. And we'll also define the length of PB as A. That is to say, PB equals to A units according to our definition. So here we know that AB is equal to 12 units and PB is equal to A, so AP will be equal to AB minus PB. That is to say, AP will be equal to AB, that is 12 units, minus PB, that is A. So in conclusion, we found out that AP is equal to 12 minus A. In the next step, I will present to you a new rule that will be actually rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So I'll repeat on rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we have also point P, point P is defined as an external point in relation to this circle because of the fact that point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore, point P is defined as an external point of this circle. So if from the external point P we draw two tangents to this circle, we will define the point of tangency of the first tangent with this circle as point A, and we will also draw a second tangent to this circle from point P, from the common external point P. We will define the point of tangency of the second tangent with this circle as point B. And according to rule number 1, the lengths of two tangents, that is to say that the length of the first tangent is PA, and the length of the second tangent is PB. And according to rule number 1, the lengths of two tangents, that is to say PA and PB, from a common external point, the common external point is point P. So the lengths of two tangents from a common external point to a circle are equal. That is to say, PA is equal to PB. So according to rule number 1, whenever you draw two tangents to a circle from a common external point, like in this drawing, we draw two tangents from a common external point P to this circle. Then, according to rule number 1, the length of those two tangents will be equal to each other. That is to say, PA will be equal to PB. Okay? So if we can implement rule number 1 in our drawing, because in our drawing we have the common external point B. From the external point or common external point B, we have two tangents to this circle. The first tangent is tangent BP. The second tangent is tangent BQ. And according to rule number 1, the lengths of those two tangents will be equal to each other. That is to say, BP is equal to BQ. But according to our definition, BP is equal to A. So from this equation, A equals to BP equals to BQ, we will conclude that BQ is also equals to A. BQ is equals to A. So we can write here that BQ is equal to A. And what is the value of QC? For the drawing, it is very easy to see that the length of line segment QC is equal to BC BC minus BQ. That is to say the length of QC will be equal to BC, that is 12 units, minus BQ, that is A. So in conclusion, we found out that QC is also equals to 12 minus A, like AP. In the next step, we will focus on the common external point A. From point A, from the common external point A, we have two tangents to this circle. The first tangent is tangent AP. And the second tangent is tangent AR. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AP is equal to AR, according to rule number 1. But we have already found out that AB equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR, we will derive that AR is also equals to 12 minus A. Now we can write down that AR equals to 12 minus A. We will continue to focus on the common external point A. On the common external point A, we have two tangents to this semicircle. The first tangent is tangent AD. Tangent AD is tangent to this semicircle at point D. Point D is the point of tangency, and we have also tangent AS. Tangent AS is tangent to this circle to this semicircle at point S. Point S is the point of tangency. And according to rule number 1, the lengths of those two tangents will be equal to each other. That is to say, AD equals to AS. But AD is equal to 12 units, according to what is given us in the question. All the sides of square ABCD are equal to each other, they are equal to 12 units. So from this equation, 12 equals to AD, that equals to AS, we'll conclude that AS is also equals to 12 units. So we can write here that AS is also equals to 12 units. So what is the length of line segment RS? It is very easy to see from the drawing that RS is equal to AS minus AR. Again, RS equals to AS minus AR. That is to say, RS equals to AS, that is 12, minus AR, that is 12 minus A. So in conclusion, we found out that RS is equal to 12, we'll open the brackets, minus 12 plus A. 12 minus 12 is 0, minus and minus is plus, so we found out that RS equals to A. So we can write here that RS equals to A. In the next step, we will focus on the common external point, point C. From the common external point, point C, we have two tangents to this circle. The first tangent is tangent CQ, and the first tangent is tangent CR. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, CQ equals to CR according to rule number 1. But we have already found out that CQ equals to 12 minus A. So according to this equation, CR equals to CQ equals to 12 minus A, we derive from it that CR is also equals to 12 minus A. So we can write here that CR is also equals to 12 minus A. And what is the value of line segment SC? The value of line segment of the length of line segment SC. From the drawing, it is very easy to see that the length of SC is actually equals to RC minus RS. Again, RC minus RS equals to SC. So SC, line segment SC, will be equal to RC, that is actually 12 minus A, minus RS, that is A. So in conclusion, we found out that SC equals to 12 minus A minus A, that is actually equals to 12 minus 2A. So right here that SC equals to 12 minus 2A. And what is the value of diagonal AC? The value of diagonal AC is equal to AR plus RC. That is to say, AC equals to AR, that is 12 minus A, plus RC, that is also 12 minus A. In conclusion, we found out that AC, diagonal AC equals to 12 plus 12, that is 24, minus A plus minus A is minus 2A. So AC equals to 24 minus 2A. In the next step, I will present to you a new rule. That will be actually rule number 2. according to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So I read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the center of this circle is at this point O, and we also have here a tangent AB here. Tangent AB is tangent to this circle at this point M. So actually point M is the point of tendency of tangent AB with this circle. We join points O and M together by a straight line. OM is the radius of this circle because of the fact that line segment OM starts from the center of the circle, that is to say from point O, and ends at point M, that is the point of this circle itself. Therefore OM is the radius of the circle, so we define it as R, abbreviation for radius. And here we have the radius OM. It is drawn to the point of tendency, that is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AB will be perpendicular to the radius OM. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. I repeat again, whenever you have a radius that is drawn to the point of tendency, like in this drawing, then the tangent will be perpendicular to that radius. In this case, the tangent AB will be perpendicular to the radius MO. AB is perpendicular to MO, that is to say, this angle equals 90 degrees, and this angle will be also equal to 90 degrees. So I actually can implement rule number 2 in our drawing. Here we will join points M and P together by a straight line. Here line segment MP is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and ends at point P, that is the point of this circle itself. Therefore, MP is the radius of this circle, and we have the radius MP that is drawn to the point of tendency. That is to say, it is drawn to point P, that is the point of tendency of tangent AB with the circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AB will be perpendicular to the radius PM. So AB is perpendicular to PM. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we know that all the angles inside the square are right angles. Therefore, angle ABC in square ABCD will be equal to 90 degrees. In the next step, we will join points M and Q together by a straight line. Again, MQ is the radius of this circle because of the fact that line segment MQ starts from point M, that is the center of this circle, and ends at point Q, that is the point of this circle itself. Therefore, MQ is the radius of this circle, and we have the radius MQ that is drawn to the point of tendency, that is to say, it is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then that tangent will be perpendicular to that radius. In this case, BC, tangent BC will be perpendicular to the radius QM. So BC is perpendicular to QM, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So in quadrilateral PBMQ, we have 1, 2, 3 right angles. I repeat again, in quadrilateral PBMQ we have 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is actual angle PMQ. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we'll get that the missing angle PMQ is equal to 360 degrees minus 270 degrees. It is 90 degrees. So we actually found out that the missing angle here, angle PMQ, is equal to 90 degrees. So in quadrilateral PBMQ, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So we can write down that quadrilateral PBMQ that has 4 right angles must be at least a rectangle. And repeat again, quadrilateral PBMQ that has 4 right angles must be at least a rectangle. And we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. So I repeat again rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle PB and Q are equal to each other. What it means? It means that PB is equal to MQ. I repeat again. According to rule number 3, PB is equal to MQ. But we have already found out that PB equals to A. So from this equation, A equals to PB equals to MQ, we will derive that MQ is also equals to A. Likewise, BQ must be equal to PM. According to rule number 3, of course. But we have already found out that BQ equals to A. So from this equation, A equals to BQ equals to PM, we will derive that PM is also equals to A. PM is also equals to A, so we actually found out that PM equals to A, so we actually found out PM is also equals to A, and we also found out that MQ is also equals to A. So, according to rule number 3, of course, so we actually found out that quadrilateral PBMQ is a square because all of its sides are equal to each other. Okay? In the next step, we will implement the Pythagoras theorem on the right triangle, big triangle, triangle ABC. Here PT is the abbreviation for Pythagoras theorem, so on the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC squared. And it equals to the sum of the squares of the perpendiculars, that is to say it equals to AB squared plus BC squared. I repeat again, according to the Pythagoras theorem, on the right triangle, triangle ABC, AC squared equals to AB squared plus BC squared. But we have already found out that the hypotenuse AC is equal to 24 minus 2A. Therefore, AC squared will be equal to 24 minus 2A squared. And it equals to AB squared. AB is 12, so AB squared is 12 squared plus BC squared. BC is also equal to 12, so BC squared is also 12 squared. So in conclusion, according to question number 1, we found out that 24 minus 2A squared equals to 12 squared plus 12 squared. 12 squared plus 12 squared is 2 times 12 squared, so I will write it down. 24 minus 2A squared is equal to 2 times 12 squared. Here we'll take out of this equation number 1. And we get that according to equation number 1, 24 minus 2a is equal to the square root of 2 times 12. Actually, the square root of 12 square is 12. Why? Because the root cancels the square and we left only with 12. Here we will add to this equation 2a and we will subtract square root of 2 times 12 and we will get that according to equation number 1, 2a is equals to 24 minus square root of 2 times 12. Here we will divide equation number 1 by 2 and we will get that according to equation number 1, 8, that is the radius of the circle, is equal to 24 over 2 is 12, minus 12 over 2 is minus 6, times square root of 2 units. I repeat again, A, the radius of the circle, is equal to 12, minus 6 times square root of 2 units. In the next step, we will define the radius of this semicircle as B. And here, dn is the radius of this semicircle. Why? Because it starts from the center of this semicircle, that is to say from point N, and then at point D, that is the point on this semicircle itself. Therefore, dn is the radius of this semicircle, that is to say it equals to B according to our definition. Likewise, nt is also the radius of this semicircle because of the fact that it starts from the center of this semicircle and ends at point T, that is the point on this semicircle itself. Therefore, nt is the radius of this semicircle, that is to say it is also equals to B units. And what is the value of line segment TC? From the drawing, it is very easy to see that the value, the length of line segment TC will be equal to DC minus dn minus nt. I will repeat again. The length of line segment TC will be equal to DC minus dn minus nt. So TC will be equal to DC, that is actually equals to 12 units, minus dn, that is actually equals to the radius of the semicircle, that is equals to B, minus nt, that is also B. So actually, in conclusion, we found out that TC is equal to 12 minus B is 12 minus 2B. 12 minus 2B, so we can write here that TC is equal to 12 minus 2B. In the next step, we will join points N and S together by a straight line. Here NS is the radius of this semicircle. Why? Because of the fact that it starts from the center of this semicircle, that is to say from point N, and ends at point S, that is point on this semicircle itself. Therefore, NS is the radius of this semicircle, that is to say it equals to B. Here we have the radius NS that is drawn to the point of tendency, that is to say it is drawn to point S, that is the point of tendency of tangent AC with this semicircle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AC will be perpendicular to the radius SN. So AC is perpendicular to SN. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. And because of the fact that angle NSC is a right angle, therefore triangle NSC, the green triangle, is a right triangle. So we will implement the Pythagoras theorem on the green right triangle, triangle NSC. But first of all, we will find out the value of the hypotenuse NC. What is the value of NC? The value of the hypotenuse NC of the right triangle, triangle NSC, will be equal to NT plus TC. So the hypotenuse NC of the right green triangle, triangle NSC will be equal to NT, that is B, plus TC, that is 12 minus 2B. So NC is equal to 12 and B minus 2B is minus B. So in conclusion, we found out that the hypotenuse NC is equal to 12 minus B. So we can write here that NC is equal to 12 minus B. Now we will implement the Pythagoras theorem on the right green triangle, triangle NSC. According to the Pythagoras theorem on the right green triangle, triangle NSC, this will be question number 2. The square of the hypotenuse is NC squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to NS squared plus NC squared plus SC squared. I will repeat again. On the right green triangle, triangle NSC, according to the Pythagoras theorem, NC squared equals to NS squared plus SC squared. So according to question number 2, NC is 12 minus B, so NC squared will be equal to 12 minus B squared. It equals to NS squared. NS is B, so NS squared will be equal to B squared plus SC squared. SC equals to 12 minus 2A, so SC squared will be equal to 12 minus 2A squared. So in conclusion, we found out that according to question number 2, 12 minus B squared equals to B squared plus 12 minus 2A squared. Here we will find out the value of the expression 12 minus 2A. The value of the expression 12 minus 2A will be equal to 12 minus 2 times A, and A equals to 2 minus 6 times root of 2. So it is actually equals to 12 Minus 2 times 12 is minus 24. Minus 2 times minus 6 is plus 2l, so it is plus 12 times square root of 2. 12 minus 24 is minus 12, so here we have 12 times square root of 2 minus 12. So in conclusion, we found out that 12 minus 2a is actually equals to 12 times square root of 2 minus 12. I'll write it down. We found out that 12 minus 2a equals to 12 times square root of 2 minus 12. So we actually can substitute 12 minus 2a in this equation number 2 by 12 times square root of 2 minus 12. So we'll do it now and we will get that according to equation number 2. Here we have 12 minus b squared. We will open the bracket. 12 minus b squared equals to 12 squared plus b squared minus 2 times 12 times b. That equals to b squared plus 12 minus 2a. We have already found out that 12 minus 2a equals to 12 minus square root of 2 minus 12 squared. Here we have b squared on both sides of the equation, so b squared will get cancelled. What is left after, from equation number 2, after we cancel b squared, what is left is actually, here we have 12 squared minus 2 minus 12b is minus 24b. That equals to, here we have 12 times square root of 2 minus 12 squared. We will take 12 as a common factor out of this expression, and what we left is from 12 times square root of 2, after we took from it 12 as a common factor, what is left is actually square root of 2. What is left for minus 12 after we took from it 12 as a common factor, what is left is actually minus 1, and all squared. Okay. So we got that according to equation number 2, 12 squared minus 24b is equal to 12 squared times square root of 2 minus 1 squared. We found out the value of this expression according to the algebraic identity that states that x times y to the power of n will be equal to x to the power of n times y to the power of n. So according to equation number 2, we get that 12 squared minus 24b is equal to 12 squared and here we will open the brackets. Square root of 2 minus 1 squared is equal to square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2 times 1. So according to equation number 2, we have 12 squared minus 24b, that equals to 2 times 12 squared plus 1 times 12 squared minus 2 times square root of 2 times 12 squared. Here we have 12 squared on both sides of the equation, so 12 squared will get cancelled. What is left from equation number 2 after we cancel 12 squared? What is left is actually, in this side of the equation we have minus 24b is equal to 2 times 12 squared is 144, and 144 times 2 is 288. And here we have 12 squared is 144, 144 times minus 2 is minus 288, times here we have also square root of 2. Here we divide the equation number 2 by 24, and we get that according to equation number 2, minus 24b over 24 is minus b. That equals to 288 over 24 is 12. Minus 288 over 24 is minus 12. And minus 12 we have also times square root of 2. Here we multiply equation number 2 by minus 1. And we get that according to equation number 2, b equals to 12 times square root of 2 minus 12. So we found out the value of b, that is the radius of the semicircle. And we have already found out that a, according to equation number 1, a equals to 12 minus 6 times square root of 2 and what is the value of a plus b? From these two equations, it's very easy to find out that a plus b is actually equals to minus 12 plus 12 is 0, and 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2 units. So in the next step, we will join points R and M together by a straight line. Here RM, line segment RM, is the radius of this circle. Why? Because of the fact that it starts from the center of this semicircle, that is to say from point M, and ends at point R, that is the point of this semicircle itself. Therefore RM is the radius of this semicircle, that is to say it equals to A units. So here the radius of this semicircle, the radius of this circle, it is actually the radius of this circle that equals to A units. the radius of this circle MR, it is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. In this case, tangent AC will be perpendicular to the radius RM. So AC is perpendicular to RM. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay, in the next step, from point M, we will draw perpendicular on RM. I repeat again, from point M, we draw perpendicular on RM. So this angle will be equal to 90 degrees. And we will extend NS, that is actually the radius of the semicircle. We will extend NS by a straight line until it intersects with the perpendicular from point M. So here, and we will define the intersection point of the extended NS and the perpendicular from point M as X. And here, NS is the radius of the semicircle. NS as a radius, it must be a straight line. And when we extended the straight line NS by a straight line, and we created the line segment NX, actually line segment NX must be still a straight line because of the fact that when you extend a straight line by a straight line, the result will be a straight line. Therefore, line segment NX, it is a straight line. Okay, so I'll write it down. Line segment NX is a straight line. I repeat again, we extended the straight line NS by a straight line, therefore the result, that is line segment NX, must be also a straight line. And we also have rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. I repeat again on rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have the straight line NX, and if we focus on the upper side of the straight line NX at point S, then the sum of the angles must be equal to 180 degrees according to rule number 4. So which angles we have on the upper side of the straight line NX at point S? We have here 90 degrees plus angle RSX. And according to rule number 4, 90 degrees plus the size of angle RSX. In total, they must be equal to 180 degrees. Here we will subtract 90 degrees from this equation, and we'll get that the size of angle RSX is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that angle RSX is equal to 90 degrees. This angle is a right angle, it is equal to 90 degrees. So quadrilateral RMSX is 1, 2, 3 right angles. Quadrilateral RMSX is 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is actually angle MXS. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We will subtract 270 degrees from this equation, and we will get that the size of angle MXS, it is actually equal to 360 degrees minus 270 degrees, it is 90 degrees. So if we know that angle MXS is a right angle, it is equal to 90 degrees. Here angle MXS is a right angle, so we actually found out that quadrilateral RMSX has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. Quadrilateral RMSX that has 4 right angles must be at least a rectangle. Quadrilateral RMSX must be at least a rectangle because it has 4 right angles, and we know that the opposite sides of a rectangle are equal to each other according to rule number 3. So here RM must be equal to SX according to rule number 3. But we have already found out that Rm equals to A, it is the radius of the circle. So from this equation A equals to Rm equals to Sx, we will derive that Sx is also equals to A. So we can write here that Sx is also equals to A. Likewise, Rs must be equal to Mx according to rule number 3. Rs must be equal to Sx according to rule number 3. But Rs or Sr is equal to A according to what we have already found out. So from this equation A equals to Sr equals to Sx, we derive that Sx is also equals to A. Sx is also equals to A. It is actually here Rs is equal to Mx. Rx equals to Mx. Rs is equal to Mx according to rule number 3. And from this equation A equals to Rs or Sr that equals to Mx, we will derive that Mx is also equals to A. Here Mx is also equals to A. So actually we found out that quadrilateral RMSX has 4 equal sides. That is to say, quadrilateral RMSX is a square, and not a rectangle but a square. And because of the fact that angle MXN is a right angle, therefore triangle, the orange triangle MXN is a right triangle, so we will implement the Pythagoras theorem on the right orange triangle, triangle MXN. So, in the orange right triangle, triangle MXN, according to the Pythagoras theorem, we will get that the square of the hypotenuse is mn, so mn square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to mx square plus nx square. I'll repeat again, according to the Pythagoras theorem, in the right orange triangle, triangle MXN, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, mn square equals to mx square plus nx square. So here, according to equation number 3, so we have mx equals to a, so mx square is a square plus nx square. Nx is a plus b, so nx square is a plus b square. So in conclusion, we found out that according to equation number 3, a square plus b square equals to mn square. But we have already found out that a equals to 12 minus 6 times square root of 2. So a square is 12 minus 6 times square root of 2 square plus b square plus a square plus a plus b square, and we have already found out that a plus b equals to 6 times square root of 2, therefore a plus b square will be equal to 6 times square root of 2 square, and it is equal to the square of the hypotenuse, that is actually mn square. So according to equation number 3, 12 minus 6 times square root of 2 square plus 6 times square root of 2 square equals to mn square. We will open the brackets on this side of the equation number 3, and we will get that 12 minus 6 times square root of 2 square is equal to 12 square plus 6 times square root of 2 square minus 2 times 12 times 6 times square root of 2 plus 6 times square root of 2 square equals to mn square. Twelve square is 144. 6 times square root of 2 square is 6 square is 36. 36 times square root of 2 square, that is 2. 36 times 2 is 72. Plus minus 2 times 6 is 12. 12 times minus 12 is minus 144. Again, 12 times minus 12 is minus 144 times square root of 2. And we already found out that 6 times square root of 2 square is 72. And it equals to mn square. We have 144, and 72 plus 72 is also 144. 144 plus 144 is 2 times 144, minus 144 times square root of 2, it is equal to mn squared. Here we will take 144, a common factor out of those two expressions. What is left from 2 times 144 after we took from it 144 is a common factor? What is left? It is actually 2. What is left from minus 144 times square root of 2 after we took from it 144 is a common factor? What is left? It is actually minus square root of 2. And it is equal to mn squared. Here we take a root out of this equation, equation number 3, and we will get that according to equation number 3, the square root of 144 is 12. 12 times the square root of 2 minus square root of 2. This is the value of mn. So in conclusion, we found out that the length of line segment mn it is equal either to 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it is equal to 9.18 units. I will repeat again, the length of line segment mn, that is actually the distance between the centers of the semicircle and the circle, it is equal either to 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. In the next step, I will summarize the lecture. Actually, we wanted to find out the length of line segment mn, that is actually the distance between the centers of the semicircle and the circle, and we defined the point of tendency of tangent AB if this circle is point B. We define the point of tendency of tangent BC if this circle is point Q. We define the point of tendency of the tangent AC if this circle is point R. We define the point of tendency of tangent AC if this semicircle is point S. And we define the touching point of the semicircle with side DC is point T. We defined line segment PB as A. So if PB equals to A and AB equals to 12, then AP will be equal to AB minus PB. That is to say, AP equals to AB, that is 12 minus PB, that is A. In conclusion, found out that AP equals to 12 minus A. Then I presented to you rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So if we have this circle and we have the common external point, point P, and from the common external point, point P, we draw two tangents to this circle. The first tangent is tangent PA, the second tangent is tangent PB. Then, according to rule number 1, the lengths of those two tangents that are drawn from a common external point to that circle, the length of those two tangents will be equal to each other. That is to say, PA will be equal to PB. So whenever you draw two tangents to a circle from a common external point, then the length of those two tangents will be equal to each other. In this case, PA is equal to PB. So we actually can implement rule number 1 in our drawing, because we have here the external point B. From the common external point B, we have two tangents to this circle. The first tangent is BP, the second tangent is BQ. And according to rule number 1, the length of those two tangents must be equal to each other. This is to say BP equals to BQ. But we have already found out that BP equals to A. According to our definition, BP equals to A. So from this equation, A equals to BP equals to BQ, we will derive that BQ is also equals to A. So we can write here that BQ equals to A. So what is the length of line segment QC? QC, it is very simple to see that QC equals to BC minus BQ. Again, QC is equal to BC minus BQ. QC equals to BC minus BQ, so QC equals to BC, that is 12, minus BQ, that is A. So in conclusion, we found out that QC equals to 12 minus A. Then we focused on the external point A. From the external point A, we have two tangents to this circle. We have tangent AP and tangent AR. And according to rule number 1, the lengths of those two tangents must be equal to each other. That is to say, AP is equal to AR according to rule number 1. But we have already found out that AP equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR. We conclude that AR is also equal to 12 minus A. So we can write down that AR equals to 12 minus A. We continue to focus on the external point A. From the external point A, we have two tangents to this semicircle. The first tangent is tangent AD, the second tangent is tangent AS. And according to rule number 1, the lengths of those two tangents must be equal to each other. That is to say, AD equals to AS. But AD is equal to 12 units. This is one side of square ABCD. So from this equation, 12 equals to AD equals to AS. We conclude that AS is also equals to 12 units. Here AS is equal to 12 units. So what is the length of line segment RS? It is very easy to see that the length from the drawing, that the length of line segment RS is equal to AS minus AR. Again, AS minus AR equals to RS. Again, RS equals to AS minus AR. AS equals to 12. AR equals to 12 minus A. So in conclusion, RS equals to 12 minus 12 plus A. 12 minus 12 is 0. So we found out that RS equals to A. Okay, then we focused on the external point C. From the external point C, we have two tangents to this circle. We have tangent CQ and tangent CR. And according to rule number 1, the lengths of those two tangents must be equal to each other. So here CQ must be equal to SCR according to rule number 1. But we have already found out that CQ equals to 12 minus A. So from this equation, 12 minus A equals to CQ equals to CR. We conclude that 12 minus that CR equals to 12 minus A. So we found out that CR is equal to 12 minus A. And what is the value of line segment SC? It's very easy to see from the drawing that SC is equal to RC minus RS. Again, SC is equal to RC minus RS. RC equals to 12 minus A. RS equals to A, so SC will be equal to 12 minus A minus A. 12 minus A minus A is 12 minus 2A. So we found out that SC, line segment SC equals to 12 minus 2A in its length. And what is the length of diagonal AC? Diagonal AC equals to AR plus RC. AC equals to AR plus RC, but we already found out that AR equals to 12 minus A, and RC is also equals to 12 minus A. So in conclusion, we found out that AC equals to 12 plus 12, that is 24, minus A plus minus A is minus 2a. So in conclusion, we found out that AC equals to 24 minus 2a. The diagonal AC equals to 24 minus 2a. Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So we have here this circle. The center of this circle is at point O. And we also have tangent AB to this circle. Tangent AB is tangent to this circle is point M. Point M is the point of tendency. OM is the radius of this circle. And we have the radius OM that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. That is to say, AB will be perpendicular to MO. So AB is perpendicular to MO. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. This is rule number 2. We can implement rule number 2 in our drawing. Here we join points M and P together by straight line. MP is the radius of this circle because of the fact that it starts from the center of the circle and ends at point P, that is the point of this circle itself. Therefore, MP is the radius of this circle. We have the radius MP that is drawn to the point of tendency, that is to say, it is drawn to point P, that is the point of tendency of tangent AB with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, AB will be perpendicular to PM. So AB perpendicular to PM, that is to say, this angle equals 90 degrees, and this angle will also equal to 90 degrees. And we know that all the angles inside the square are right angles, therefore, angle ABC in square ABCD is equal to 90 degrees. We join points M and Q together by a straight line. Here MQ is the radius of this circle. And we have the radius MQ that is drawn to the point of tendency. That is to say, it is drawn to point Q that is the point of tendency of tangent BC with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. In this case, BC, the tangent BC will be perpendicular to QM. So BC is perpendicular to QM. That is to say, this angle equals 90 degrees, and this angle will also equal to 90 degrees. So actually, in quadrilateral PBMQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle. In total, they must be equal to 360 degrees. The sum of 3 angles is 270 degrees, plus the size of the fourth angle that is actually angle PMQ. In total, they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, we subtracted 270 degrees from this equation, and we found out that the angle PMQ is equal to 360 degrees minus 270 degrees is 90 degrees. So this angle equals to 90 degrees. Therefore, in quadrilateral PBMQ, we have 4 right angles, and any quadrilateral that has 4 right angles, it must be at least a rectangle. So quadrilateral PBMQ must be at least a rectangle. And we have rule number 3, that the opposite sides of a rectangle are equal to each other. That is to say, PB must be equal to MQ. PB must be equal to MQ, but according to our definition, PB equals to A. So from this equation, A equals to BB equals to MQ, we will derive that MQ is also equals to A. Here MQ is also equals to A. Likewise, BQ equals to PM, according to rule number 3. But we have only found out that BQ equals to A. So from this equation, A equals to BQ equals to MP, we will derive that PM is also equals to A. PM equals to A, so we found out that quadrilateral PBMQ is a square. Why? Because of the fact that all of its sides are equal to each other, they are equal to A. Then we implemented the Pythagoras theorem of the right triangle, triangle ABC, according to the Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AC, and the square of the hypotenuse is AC square. It must be equal to AB square plus BC square. We have already found out that AC equals to 24 minus 2A, so AC square will be equal to 24 minus A square. and it must be equal to AB square. AB is 12, so AB square is 12 square, plus BC square. BC is 12, so BC square is 12 square. So in conclusion, we found out that according to equation number 1, 24 minus 2a square equals to 12 square plus 12 square is 2 times 12 square. We took out of this equation number 1, and found out that 24 minus 2a equals to the square root of 2 times 12. Why times 12? Because of the fact that the square root of 12 square is equal to 12. Why? Because the root cancels the square and we left only with 12. So in conclusion, we found out that according to equation number 1, 24 minus 2a equals to square root of 2 times 12. Here we added 2a to this equation and we subtracted square root of 2 minus 12 from this equation number 1, and we found out that 2a equals to 24 minus square root of 2 times 12. We divided this equation number 1 by 2, and we got that a equals to 12 minus 6 times square root of 2. That's actually the radius of the circle. Then we defined the radius of the semicircle as b, therefore dn equals to b and b is also equal to b. What is the value of TC? TC will be equal to DC minus dn minus nt. TC equals to DC minus dn minus nt. So TC equals to DC, that is 12, minus dn, that is b, minus nt, that is also b. So in conclusion, we found out that TC equals to 12 minus b minus b, 12 minus b minus b is equals to 12 minus 2a. So in conclusion, we found out that TC equals to 12 minus 2b. Here, TC equals to 12 minus 2b. And then we found out we actually connected together points N and S together. We connected points N and S together by a straight line. NS is the radius of the semicircle, that is to say it equals to b units. And we have here the radius NS of the semicircle. It is drawn to the point of tendency, that is to say it is drawn to point S, that is the point of tendency of tangent AC with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then the tangent must be perpendicular to this radius. So AC is perpendicular to SN, that is to say this angle equals to 90 degrees and this angle will also equal to 90 degrees. So angle NSC is the right angle, therefore the green triangle is the right triangle. So we can implement the Pythagoras theorem on the green right triangle, triangle NSC. We calculated the value of the hypotenuse NC. What is the value of the hypotenuse NC? The value of the hypotenuse NC is equal to NT plus TC. NC is equal to NT plus TC, but NT is equal to B, and TC equals to 12 minus 2B. So in conclusion, we found out that NC equals to 12 and B plus minus 2B is minus B. So in conclusion, NC equals to 12 minus B. So we can write here that the hypotenuse NC is equal to 12 minus B. Then we implemented the Pythagoras theorem on the right green triangle, triangle NC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is NC square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to NS square plus SC square. NC, the hypotenuse equals to 12 minus B, so NC square is 12 minus B square. It equals to NS square. NS is B, so NS square is B square plus SC square. SC is 12 minus 2A, so SC square is 12 minus 2A square. Then we calculated the value of 12 minus 2A. What is the value of 12 minus 2A? 12 minus 2A is equals to 12 minus 2 times A, and A equals to 12 minus 6 times square root of 2. So here we open the brackets, minus 2 times 12 is minus 24, minus 2 times minus 6 is plus 12. So in conclusion, we got here 12 minus 24 plus 12 times square root of 2. 12 minus 24 is minus 12. And in conclusion, we found out that 12 minus 2A equals to 12 times square root of 2 minus 12. That is to say, we can substitute 12 minus 2A in this equation number 2, by 12 times square root of 2 minus 12. We did it and we got that 12 minus b square. What is the value of 12 minus b square? 12 minus b square equals to 12 square plus b square minus 2 times 12 times b. That equals to b square. And here we substituted 12 minus 2a by 12 times square root of 2 minus 12 square. And here we have b square on both sides of the equation, so b square will get cancelled. And we left only with 12 square minus 2 times minus 2 times 12b is minus 24b. So in conclusion, we got that according to equation number 2, 12 square minus 24b equals to 12. So here we took 12 as a common factor out of this expression. So what is left from 12 times square root of 2 after we took from it 12 as a common factor? What is left is square root of 2. What is left from minus 12 after we took from it 12 as a common factor? What is left is actually minus 1. So in conclusion, we got that this expression is equal to 12 times square root of 2 minus 1 square. And then we got the 12 square minus 24b equals to, here we use the algebraic identity that x times y to the power of m equals to x to the power of m times y to the power of m in order to calculate the value of 12 times square root of 2 minus 1 all squared. So it will be equal to 12 square times square root of 2 minus 1 square according to this algebraic identity. So we got that according to equation number 2, 12 square minus 24b equals to 12 square. Here we open the brackets of square root of 2 minus 1 square. Square root of 2 minus 1 square equals to square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2 times 1. So here we have 12 square minus 24b equals to, we open the brackets here, 12 square times 2 is 2 times 12 square, 12 square times 1 is 1 times 12 square, minus 2 times square root of 2 times 12 square. So here we have 12 square on both sides of the equation. After we cancel 12 square, we left with minus 24b, and here 12 square is 144, 144 times 2 is 288, that equals to 12 square is 124, 124 times minus 2 is minus 288 times square root of 2. Here we divided equation number 2 by 24 and we got that minus 24b over 24 is minus b. 288 over 24 is 12, and minus 288 over 24 is minus 12, so in conclusion we got that according to equation number 2, minus b equals to 12 minus 2, minus 12 times square root of 2, we multiplied the equation number 2 by minus 1, and we got that b equals to 12 times square root of 2 minus 12, and we already found out that a equals to 12 minus square root of 12 minus 6 times square root of 2, and a plus b, it is equal to, here, we have minus 12 plus minus 12 is 0, and 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2, so in conclusion, we found out that a plus b equals to 6 times square root of 2. Okay, then, here we added points, we joined points R and M together by a straight line. Rm is the radius of this circle, that is to say it equals to A. So here we have the radius Rm or Mr, it is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency or tangent AC with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, tangent AC will be perpendicular to the radius Rm. So AC is perpendicular to Rm, that is to say this angle equals to 90 degrees and this angle will be also equal to 90 degrees. In the next step, we made a construction from the center point M. We draw perpendicular on RM, so this angle equals 90 degrees, and we extended NS by a straight line until it intersects with the perpendicular from point M, and we define the intersection point of the extended NS and the perpendicular from point M as X. So here we have NS is the radius of the semicircle, that is to say it equals to B units, and radius must be a straight line. So therefore NS is a straight line, and when we extended the straight line NS by a straight line, we got a straight line. The result must be a straight line. So the result of the extension of NS, that is actually NX, it must be a straight line. Okay, so in conclusion, NX is a straight line, and we have also rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. So we found out that NX is a straight line, so if we focus on this side of the straight line NX at point S, the sum of the angles must be equal to 180 degrees. Which angles we have at point S? We have here 90 degrees plus angle RSX. So according to rule number 4, 90 degrees plus the size of angle RSX, in total they must be equal to 180 degrees. According to rule number 4, we subtracted 90 degrees from this equation, and we got that the size of angle RSX equals to 180 degrees minus 90 degrees, it is 90 degrees. So angle RSX is equal to 90 degrees, so we have here quadrilateral RMSX with 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the 4th angle, that is actually angle MXS. In total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation, and we found out that the 4th angle, angle MXX, equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So actually in quadrilateral RMSX, it has 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle. So quadrilateral RMSX with four right angles must be at least a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say RM must be equal to SX according to rule number 3. But we know that RM equals to A, so from this equation A equals to RM equals to SX, we will derive that SX is also equals to A. Here SX is also equals to A. Likewise, MX must be equal to RS. Here MX must be equal to RX according to rule number 3, that the opposite sides of a rectangle are equal to each other. But we have already found out that RS equals to A. So from this equation A equals to RX equals to MX, we will derive that MX is also equals to A. MX is also equals to A, so we found out that quadrilateral RMSX is a square. And because of the fact that angle MXN is a right angle, therefore triangle MXN, the orange triangle MXN is a right angle. So we implemented the Pythagoras theorem on the right orange triangle MXN. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, the hypotenuse is Mn. So the square of the hypotenuse is Mn square, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to mx square plus nx square. So here mx is A, so mx square is A square, nx is A plus B, so nx square is A plus B square, and it must be equal to the square of the hypotenuse, that is actually Mn square. We have already found out that A equals to 12 minus 6 times square root of 2, so A square is 12 minus 6 times square root of 2 square. A plus B is 6 times square root of 2, so A plus B square will be equal to 6 times square root of 2 square. and it equals to mn squared. We open the brackets here, and we got that 12 minus 6 times square root of 2 squared equals to 12 squared plus 6 times square root of 2 squared minus 2 times 12 times 6 times square root of 2 plus 6 times square root of 2 squared. 12 squared is 144. 6 times square root of 2 squared is 72. Minus 2 times 6 is 12. 12 times 12 is minus 144. Minus 2 times 6 is minus 12. Is minus 12 times minus 12 is minus 144 times square root of 2. And 6 times square root of 2 is 72. So in conclusion, we found out that 72 plus 72 is 144. 144 plus 144 is 2 times 144. So according to equation number 3, 2 times 144 minus 144 times square root of 2 equals to mn squared. Here we took 144 as a common factor out of those two expressions. So what is left from 2 times 144 after we took from it 144 as a common factor? What is left? It is actually 2. And what is left from minus 144 times square root of 2 after we took from it 144 as a common factor? What is left? It is actually minus square root of 2. Okay, so in conclusion, we got that 144 times 2 times minus square root of 2 equals to mn squared. We took out of this equation number 3, and we got that mn, the line segment that we are looking for, is equal to the square root of 144 is 12 times square root of 2 minus square root of 2 units. So in conclusion, we found out that the distance between the centers of the semicircle and the center of the circle, that is actually line segment mn, it is equal to either 12 times square root of 2 minus square root of 2 units, so in terms of numbers, it equals to 9.18 units. I will repeat again, the distance between the centers of the semicircle and the circle itself, it is equal, that is actually line segment mn, it is equal to either 12 times square root of 2 minus square root of 2 units, so in terms of numbers, it equals to 9.18 units. Okay, thank you very much.